Hey, algebra. Got catfish in the back here. Today we're going to solve systems of linear equations using substitution. We're going to talk about what that means, builds off of what we've done so far. Well, without further ado, let's go. All right, quick recap of solving by graphing. Okay, step one, set up each equation to be graphed in slope-intercept form. We already do that. That's y equals mx plus b, where my slope is, that's not what I wanted to do. My slope is m, and my y-intercept is b. Okay, it's going to usually be set up for you like that. Then the next thing we're going to do is graph each equation, and we're going to look for where they intersect, and then write the ordered pair. So those were our solutions, right? We had x coordinate and y coordinate. I wrote subscript s to indicate solution. Last bit. Now at least we check our answers by substituting, which just means we put back in, we plug back into both equations. Okay. So how do we solve by substitution? Solve a system of equations. We have two equations, equation 1, equation 2. Equation number 1, we already have y by itself. It equals 6x minus 11. Equation 2, negative 2 times x minus 3 times y equals negative 7. I'm going to rewrite this equation number 2 in terms of x, which means the only variable that will appear is x. So negative 2 times x minus 3, parentheses, 6x minus 11. Why did I write that? Because y equals 6x minus 11. So I replace the letter y with this expression because y is 6x minus 11. So first thing I do is I get rid of parentheses by using distributive property. Okay. I have negative 3 times 6x, which is negative 18x. Negative 3 times negative 11 is positive 33. Combine like terms, negative 20x plus 33 equals negative 7. I'm going to get x by itself by first removing any constants away from the variable term. So I subtract 33 from both sides, and I get negative 20x equals negative 40. I have negative 20 times x, so I divide both sides by negative 20 to get 1x. That gives me x equals 2. Then I take x equals 2, and I plug it all the way back in for this x. Okay, so I have equation 1 now. I have y, which is what I'm trying to find. It's already by itself. See that? It's already alone. 6 times 2 instead of 6 times x minus 11. Get rid of parentheses by doing my multiplication. I have y equals 12 minus 11, which is y equals 1. So my solution to this system is 2, 1. It's an ordered pair. So let's try another one. It's a sample problem. Make sure you're writing these down. Equation 1, equation 2. Y equals 5x minus 7. Then I have negative 3x minus 2y equals negative 12. I'm going to rewrite equation 2 in terms of x, which means only x's will appear in my equation. Okay, so I have negative 2 times y. In this case, y equals 5x minus 7. 5 times x minus 7, and it equals negative, that's not the number 12. Let's fix it. Negative 12. Okay. Then I need to get rid of my parentheses, so I distribute negative 2 into the parentheses. This is what I get. I combine like terms. Negative 13x plus 14 equals negative 12. I subtract 14 from both sides. Negative 13x times x equals negative 26. Divide both sides by negative 13. X equals 2 again. Interesting. So remember, I'm going to take this 2. It's my input. I'm going to put it in for x to get my output, y. So let's do that. Equation 1, y equals 5 times positive 2 minus 7, which 5 times 2 is 10. Y equals 3. This is the y coordinate. This is the output. So the input of 2 and the output of 3 is a solution for both equation number 1 and number 2. So when do we graph and when do we use substitution? The choice is really yours. Sometimes graphing helps to visualize our data. If you're comparing two things, right? Comparing like phone plans, car insurance, buying different stuff, right? Usually more than one thing at a time, okay? It can help us visualize the data so we can see what's happening. Using substitution, I'll say subs, when you want to know where two equations meet. So we can visualize let's take a phone plan. We can visualize our information, but if I want to see where one phone plan starts to become more expensive than another, I need to know where that point is, okay? Or insurance, when insurance becomes too expensive, or where one costs more than another one, I would like to know where that point is. It helps me make a better decision. I prefer to use substitution all the time because it gives me the point, whether it's a fraction, decimal, or anything like that. Graphing is good to visualize, but sometimes it's hard to tell what the solution actually is because we're trying to, we got our graph here and our two lines are crossing here, but our tick marks don't line up. So we're kind of floating in space there, okay? So that's where I would use substitution. Recap. Systems of equations have more than one equation. That's why it's a system. There's many of them. Okay. Oops, we don't need an S, it's singular. Okay. Substitute when we know X or Y in terms of variable. Okay, we were going to rewrite one equation in terms of only one variable. So we kept rewriting equation number 2 and only using X because we knew we could replace the letter Y with, the expression that had X in it. One of them, it was 5X minus 7. Okay, and so that allows us to solve for X, and then we would use that X to solve for Y. Okay, so we want to rewrite the one equation in terms of only one variable. Then we solve, sorry, that's bad arrow. Then we solve for that variable. Then we plug in the solution to one of the original equations. Okay, and it could be either one. I just chose the simplest one, the one that already had Y alone. So your assignment is going to be the solving systems worksheet by substitution. Okay, and code word is going to be the number 14. Come tell me that when you're done. Write it down in your notes. You better have stuff written down. All right. I hope this helps. You know how to find me. Good luck.